Okay, we're transitioning to the final page of the 1.1 notes for Algebra 2, and we have two more goals. We're going to try to figure out increasing and decreasing intervals, and then we're going to find the average rate of change. Okay, in a graph, you have parts of the graph that are uphill and parts that are downhill, and that's what's meant here. Increasing is uphill, and decreasing is downhill. And since every hill in the whole world is both uphill and downhill depending on the direction you're walking on that hill, we are going to always use this convention. You're going from left to right when you make that decision. So if you come down here and you see this picture here, we're going to try and first of all find the places where this is increasing, and I'll do that with a green color, increasing. And this thing is increasing going uphill from there to there. And the interval notation is the easiest. The starting x value here is 0. I know it says at the point 0, -1, but the x value is 0 there. And it continues to go uphill until your x value goes all the way over to 2. And then the two endpoints don't count. And the reason they don't count is it's impossible to tell, for instance, whether this point is the start of the uphill section or the end of this previous downhill section. So you simply don't include these when you do it, and it would be a round parenthesis. Now, once again, it's important to remember these are both x values, starting x value, ending x value. This is not a point, x comma y. That point 0, 2 would be right there, and you can see it has nothing to do with this graph. It's not even on the graph. Okay, for what values is the function going downhill or decreasing? I'll switch to orange to highlight that. It's going downhill from -infinity on the left all the way until you get to x equals 0. So -infinity on the left, and all the way until the x zeroes out here in the center of the graph. So -infinity to 0. It doesn't include either one because of the fact that you can't include -infinity, the left-hand member. And here, x equals 0, you can't decide whether you're in the orange or the green, in other words, the downhill or the uphill, so you just don't include it. Now there is one other section that's downhill, and that's from starting at x equals 2 to all the way over to x equals 4. So that downhill section is another decreasing interval. Okay, and the final one here is something that is used to introduce some calculus concepts later, and it's called an average rate of change. The irony is, even though this is something that will help you in the beginning of calculus, knowing an average rate of change, the skills involved are all Algebra 1. All we're going to be doing is using the slope formula in the end. y2 minus y1 over x2 minus x1. Recall that the y's measure up and down, so that's the rise, and side to side is the run. This is rise over run if you're familiar with that definition of slope. All right, so what you do is they're an interval, in this case from 1 to 7. So you find x equals 1 and make a dot on the curve there, and x equals 7 and you make a dot on the curve there. And you connect those dots and find the slope between them, and that's called the average rate of change in this section. So we're going to connect them, and if you can find the slope of that segment, you're home free. So what you're going to do here is take the the slope, which is m, and you're going to take the difference in the y values up top and the difference of the x values in the bottom. Now I'm going to show you the way I prefer you guys to do this. 4 kangaroo pockets and 2 minus signs as your template. You're going to be filling the second y in here and the first y in here, the second x in there and the first x in here. You're better off, though, filling this in from the bottom up with x on the bottom. X measures run, that's why it's on the bottom. So let's start with this second point over here. It's actually arbitrary which one you start with, but I'm going to start with this point over here and call that the second point. So it's 7, 5. You're going to go 7 for the x, 5 for the y. And this one's at 1, 2. 1, 2, right here. So you go 1 on the bottom, the x always goes on the bottom, and 2 above it. Now when you subtract 5 minus 2, you get 3, and 7 minus 1, you get 6. So when you simplify that to 1/2, you've got your slope for that segment, and it's called the average rate of change for the slope for the curve. This is a downhill section for a short amount of time, and an uphill section for most of this trip. So if you average a little bit of minus and a lot of plus, positive slope, you'll end up with a positive slope. And by the way, you can see the 1/2 slope in the segment. 1 up, 2 over, 1 up, 2 over, 1 up, 2 over to get over here. Okay, the next one here uses the same graph, and we're going to get a different answer because we're starting and stopping in different spots. So we're going to start with x equals 1, which gives us this point again. But instead of going all the way over to 7, we're just going to go over to 3. And then we're going to draw that little segment there and find its slope. So the slope of that line, once you set your template up, you're just going to plug these points in. We said it was 3, 1, and 1, 2. So 3, 1, and 1, 2. And you could switch those around, but you always put the x on the bottom and the y that goes with it on top, right above it. So the top here gives -1, the bottom gives 2, and our slope is -1/2. And that's also called the average rate of change. You can actually see it here. It goes down 1 and over 2 on that little segment. Whereas the other one, where we had a slope of 1/2, goes up 1 over 2, up 1 over 2, up 1 over 2. So that does it for the 1.1 notes. I hope this helps you.